pipe with 20 centimeters diameter is filled to a some depth 1/3 of its diameter. What is the area of flow? Okay, so the only thing we're given in this problem is the depth, or the height, and it's 1/3 of its diameter. So let's just calculate that. We'll call it D, depth D, and that would be equal to 1/3 of 20 centimeters, which is 6.67 centimeters. The units aren't too important. Everything's going to be in terms of centimeters in this problem. So we know what's our radius too? Our radius is just half of that, right? So our radius is just 10. So let's try to get, this is the center of our circle here. This is our pipe. And we have some water level, right? And we know that it's 6.67 high. So it's not quite as high as the radius. So it's a little under the center point. Let's say it's like right here. So bang, there's our, let me straighten that out. So there's our water level, right? And we want to know the area of this region here. Well, the problem with that is we don't really have any information about it. All we know is that this point here is 6 points. Oh, fuck. Bang. Shit, still doing the lines. How do I get rid of this? There we go. This is 6.67 because that's what we just figured out. And then we also know that this is 10 minus 6.67, right? Because this has to be 10. So this right here is 3.37. But we don't really know much other than that. So what we can do is we can find the section of this whole region here. If we could just find this angle somehow, then we'd be able to find the whole sector of this circle and then subtract it by this triangle, and then that would give us our depth, right? So let's try and do that. The first thing we can do is find this length here. I guess we don't need that length. We can let's find this value theta. Excuse me. So we know this is 10 too, right? So now we have a right triangle that looks something like this. 10, 3.37, and we're interested in this value of theta, right? So this is adjacent, that's hypotenuse, so you'd use sine theta is going to be 3.37 over 10. Theta equals inverse sine of 3.37 over 10. And that theta is going to be equal to 70 degrees. Right? So now we have this value right here, this theta, but we want this whole thing. So all we have to do is multiply that by 2. So we'll call this phi equals 2 times theta equals 140 degrees. All right, so now we got that angle. So now things are looking pretty good because we have this value of 3, which is phi, which is equal to 140 degrees, which will help us. Phi will be the only thing we need to solve this whole section, right? And to find this triangle, well, we can just get this base right here and then multiply base times height and find the area of that triangle, multiply by 2, and we'll get that. So let's do this red part because I just shaded that. So we'll call this A whole. And that's going to be 140 degrees over 360 degrees times pi r squared. So pi, and what's the radius again? The radius is 10. And this is all in terms of centimeters. So that's going to give us 122 centimeters squared. Oops, sorry. So now we have this this whole red region right there. Now we just need to find this big triangle region. I'll put it in green. I want to find this triangle here. So we need to find this base because we have, so far with our triangle, we have 10, 3.37. So to find this base value, we just do a squared plus b squared equals c squared. A equals root c squared minus b squared. A equals root. So 10 squared would be 100. Type in 3.37 squared. 3.37 squared is 11.4. And that's going to equal roughly 31 centimeters. Oh wait, no, it's going to be roughly equal 9.4. Sorry, centimeters. Jumped ahead. So now we have 9.4 here. So now again, we can find the area of this triangle right here. Let's just do that, fine. We'll just do the area of this triangle. We'll call it A tri, like little triangle. That's just going to be 1/2 base times height, which would be 1/2 3.37 times 9.4. And that's going to be equal to roughly 15.5. And now, to get this big triangle, the big green triangle, we would just multiply this triangle by 2, right? Because there's just 2 of them. So a triangle with the big T equals 31. So now we're finishing the problem here. We just have to take this red section and minus it by the green section. So A water flow, and I'm using A to denote all these because it's all area values. Like this is centimeters squared technically. So we take our red, which is 122 squared, and we'd subtract that by 31 centimeters squared, and we are left with 92 centimeters squared. Yep, that's your problem.